In this video series, we are going to learn Monte Carlo simulations from the very basics. Okay, so over the next few months, I'm going to add a number of videos to this playlist. We'll start with very simple examples so that we can understand the basics, and then we will learn how to apply the Monte Carlo simulations to real life use cases like stock price prediction, portfolio optimization, the risk prediction, maybe to understand some material properties, etc. Right? So I will add more and more real world use cases in a few months. But in the next few videos, we are going to learn the very basics of Monte Carlo simulations. Okay. Now, in our real life, whether it is personal or professional life, we often ask questions like, what are all the possible, likely possible outcomes? And among those one, which one is the most possible outcome, right? So Monte Carlo simulations, it tries to answer the same questions. Now let's take an example. So let's say here we have an outcome y, which is dependent on a number of variables like x1, x2, x3, and xn. Right now, we are interested in what are all the possible outcomes for y given these input variables. Okay. Now, what we do in simulations is we try to design this virtual experiment. We call it virtual because we will be performing this experiment on a computer. Okay. Now, okay, let's take this example so that we can understand easily. So let's say we are trying to predict the number of sales next month. Now, we are keeping all other external variables fixed except these three. Let's say the number of customers, the interest rate, and the number of new products next month. Okay. So our sales for next month are going to be dependent on only these three values next month. Okay. Now let's say we already know the functional form. So for example, given these three values, we know how to compute the sales for next month. But even then, the uncertainty comes because these three input variables themselves have some uncertainty in them, right? For example, let's take the number of customers. Let's say we have currently 1000 customers. Now every month we are going to have 5 to 10 customers increase, right? So next month we may have 1005 or 1006 or 1007 or even 1010, right? So our first variable number of customers itself, we have a range, right? We don't have a single number. We have a range, or we have a known probability distribution based on the historical data. Now, similarly, the interest rate. Let's say the current month interest rate is 5%. The government might increase the interest rate next month by, let's say, 0.5 points. Now, it may increase, it may not increase. But let's say we know we are 75% confident that they don't increase, but there is 25% chance that they will increase by 0.5 points, right? So our second variable, interest rate, can also be either 5 with probability 75%, or it can be 5.5 with probability 25%, right? And finally, our third variable, number of new products. Okay, let's say the current month we have 10 products, and let's say every month we will be launching 1 to 2 new products. So we may launch one product or we may launch two products. So next month we may have 11 products or we may have 12 products. Let's say they are equally probable. So even for this simple problem with only three variables, each variable has its own distribution, right? With different values with different probabilities. Okay, so that's where the uncertainty is coming from. Now in simulation, what we do is we repeat the experiment many number of times. So the first experiment is, given that we know the value of number of customers is going to be between 1005 to 1010, what we do is we pick one value. We randomly pick one value from this probability distribution or the range, the likely range, right? So we pick one value for number of customers. We pick one value for the interest rate. We pick one value for the number of new products. It can be 11, for example, right? Now we have three exact values for these three variables. Then what we do is we plug in this function. Let's say that we already know the functional form. We compute the number of sales next month. Okay, so we did one experiment. We have one outcome or one value for the sales next month. Then what we do is we pick one more value for each of these three variables. Okay, again from the known range or the known distribution. So we draw three values for these three variables. We again compute the sales for next month. Okay, so we have the second value for the sales next month. We repeat this experiment many number of times. In the next couple of videos, it will be clear to you why we need to repeat this experiment so many number of times, even millions of times. After we repeat the experiment, let's say 1 million times, we will have 1 million values for the sales next month. Okay, then we use those 1 million values to find out again the distribution of sales next month. From the distribution, we can find out what is the most likely number of sales and how confident or how likely that to happen. Okay, I hope that concept is clear. But again, we are going to see a number of very simple examples so that it will be clear to you. Okay. Now, here I have listed few applications, but as I was saying, Monte Carlo simulations, they have applications in every area one can think of. Okay. Now, we discussed this. For example, in this artificial intelligence space, the two areas where they are mostly used are this optimization and search, right? For example, we can have millions of outcomes for a given problem, right? And when we search through that millions of outcomes, it's impossible to visit assess each outcome, how likely it is possible, right? So Monte Carlo simulations, they can guide us to the most probable outcome in a few steps. Okay, and so the simulations, they depend on we need to understand or we need to have good understanding of a number of concepts in order to be able to design the simulations and then run the simulations and do the inference, etc. Right? Now those are the probability, the random numbers, the different sampling techniques, the probability distributions, this law of large numbers, why we need to do many number of experiments, and this virtual experiment or the simulation design itself, right? So we will be covering all these over the next in this playlist, but we'll start very basic. So I assume you are maybe even new to probability. So in the next few videos, we'll start with a coin or a dice, the 6-phase dice, and we will see how to compute the probability theoretically and then using the simulations. So we build up the concepts very slowly, and eventually we will work on problems like these with real world use cases. Okay. Thank you very much.